This video will talk about the application of marginal product of labor and the relevance of the optimization of it to running firms. An integral component of running a business that operates at its peak is the understanding of the production function. This is a relationship between amount of resources employed and total product. It is important to understand that total output of a firm is not an indicator of the profitability of a business. A firm could be producing a high amount of produce, but the marginal product, which is the change in total product from an additional employee, is not at its highest. Essentially, this concept is about employing and hiring the correct amount of labor or workers so that productivity and, more importantly, profit can be maximized. This would be the amount of workers where marginal product is the greatest. The law of diminishing marginal returns states that as more of a variable resource is added to another resource, marginal product will eventually decline. Or, as the number of new employees increases, the marginal product of an additional employee will at some point be less than the marginal product of a previous employee. So, in the case of this study, as the amount of workers in a firm will increase, the marginal product of the firm's output may initially increase, but after a certain point it will decrease. The aim of this case is to produce a mathematical application that employers may use to achieve the optimum level of marginal product. In other words, how many workers should be hired so that marginal product is at its greatest? Assumptions that need to be made when applying this mathematical tool are as follows. One is the similarity in abilities or productivity of each worker. No one worker has a distinguishing feature that allows him or her to affect the marginal product disproportionately. This is important in this case because it also relates to wages. The wages of each worker will be the same as the productivity of each is equal. Therefore, as wages are constant amongst all employees, for the sake of the model, we are able to disregard this as a variable in a mathematical application and focus solely on marginal product and labor as variables. Another assumption is that costs are independent to the firm's production function. Although this may not be the case in a real-world scenario, this assumption needs to be made in order to eliminate any contributing factors that would affect the examination of production function. This graph depicts the total product of labor. It shows the quantity of product produced at a level of labor, where Q is the quantity and L is the labor. Since the slope of a function is also the derivative, in this case the derivative of the total product of labor is marginal product of labor. The equation for marginal product of labor is calculated by dividing the change in quantity by the change in labor, which is the difference between Q2 and Q1 divided by the difference between L2 and L1. Here, the marginal product of labor curve is generally negative sloping, due to the fact that the change in total product from an additional employee will decrease over time. However, the marginal product curve is actually hump-shaped in reality, with an initial positive slope that gives way to a negative slope. This is proving the point that marginal product will firstly increase at an increasing rate as quantity of labor rises, then increase at a decreasing rate to a certain point from which it will then decrease, and eventually become negative. This is where hiring an additional employee results in less total product. To further the understanding of the concept, this case study can be observed. Company A is a timber producing company where workers are producing processed pieces of wood. Given L is the number of workers and Q is the quantity of processed wood, the equation Q equals L plus 30L squared minus L cubed can be used to calculate the quantity of wood produced given a number of workers. And the marginal product of labor is given as the derivative of this, which is dq over dl equals 1 plus 60L minus 3L squared. The ideal number of workers needed in this situation is calculated to be 20. After this point, the quantity of total product will decrease. The results of the quantities obtained show that the total quantity of timber produced increases at first with numbers of workers, but after a point it decreases, as can be seen on the graph after L equals 20. This may be seen on the marginal product of labor graph, where a positive slope indicates that marginal product is increasing at an increasing rate. When the slope is negative, it indicates that marginal product is still increasing but at a decreasing rate. This is true only where the marginal product of labor curve is above zero. When the curve is below zero, it indicates that marginal product is now decreasing as number of workers increases. When comparing the two graphs, it can be seen that when the slope is zero on the total product curve, which occurs at its highest point, for the same quantity of labor, marginal product is also zero. This is the optimum point of productivity. Adding more labor would cause the total product to decrease after this point. When the slope of marginal product of labor becomes negative, this is indicative of the law of diminishing marginal returns. Here, total product is still increasing but at a decreasing rate. By using this approach to business and employment, managers and firm owners are able to approach the application of marginal product in a mathematical manner. This could be revolutionary because rather than using trial and error methods or comparison of past business data, a company now has the potential ability to calculate the appropriate number of staff they should hire prior to making the mistake of hiring too many or too less and not optimizing their marginal product of labor.